Well, in the last session, we have discussed about this data structures of the Python, pandas, and we have dealt with the data that we have seen how to look at the data, how to access the how many rows of data and how many columns of the data, and trying to retrieve only the specific ones using lock and ilock. Now, this is a session we are talking about how to create your own kind of data. So how do we create a new series of data? How do we create a new data frame? So how we can able to write programming to generate our own kind of data. So coming to the point here, so we're creating a series of objects that is we're going to create a column of values. So simply we're trying to import the pandas, and in the next step I'm trying to use series because it's coming from the pandas only. Then I'm actually creating this, if two values, I'm not creating more than one. So to show you that, it's just created this way. So when you observe that, we have a series of index values that is 0, 1, 2, 3 because the index starts from 0 to n minus 1. And so I'm going to create a new object again using series. So more than one. So it is going to give you this way. At this case, if you understand, we have an index parameter, right? We have an index parameter that we are actually passing to as a values. So it's not going to generate a series of values. Rather, it's going to take our values that we have mentioned over here. So it's simply the series, these values are actually the column values, we can actually say, right? So how do we create a new data frame? Because we just created a series, that is, we are intentionally creating a column of values. But how do we create a more than one column? Using a data frame, because a data frame represents the complete data. That means it may have a number of columns. Who knows it, right? So how do we create in the sense? So when you say the scientist is equals to the data frame is also an object which is coming from the pandas, and saying that here, say the name, because you're just trying to pass a dictionary of values. A dictionary in the sense, in the Python data structures, we create a dictionary in this way. This is a key we call it as, and this is the values for this key. The names are this. The occupation is chemist and statistician for this, right? So keep on creating same way the born and what date they have they born, and when they died, and we have also have age over here. What is their exact ages? So I'm trying to print the same scientist over here. So we got the data got generated here this way, the very structured full data, right? And look at here, we got the series of index values because we are not talking about an index for this anyway. The name is the Rosen Franklin and William Gossett. So we can see that here, this is a key, these are the values for that. So this is the key, this is the value. So Rosen Franklin and William Gossett. The occupation is chemist and statistician. So we have mentioned same way the occupation is a key, and these are the values for the same. And the born on these dates, the died on these dates. If you subtract this to, you're going to get these ages as well, right? So coming to the next point, if you can observe, we can even generate, we can even mention the index that we wanted to have a manual kind of indexes rather than having a series of values. So how are we going to do that? Let's say I'm going to do the same thing over here, but a bit different. When you're creating a data frame, pd.data frame, right? So let's say this, and I'm saying that we have a predefined parameter called data. Then you're trying to talking about the data, the purely that comes under, as values of the columns. So this is something that saying over here, and then I'm talking about this, providing a dictionary of values. So let me copy these things and pasting over here to save the time, right? And let's say we're going to paste this. You'll understand why I'm taking from here. And this, look at here, yeah, and paste. And they have died on so and so date. Look at here, yeah. and they have ages also there, and I'm taking, right, so coming to the endpoint. This one I'm taking in, copy, paste it here. Then we have something called, because I'm not still ended over here, so I'm saying that here, index. There is, I'm trying to provide an index rather than it's giving a sequence of values. It's going to give what I'm going to provide the values over here. So I'm not interested to provide, have the sequence of values. So what I'm trying to say here, I want to have these the names as an index, so that this particular column, the name column, it's going to move as an index, so that the Rosen Franklin, the William Gosset would be index values. So those are not going to be like index numbers. So how should I provide in sense? Same way like as we have provided over here for the series. So the index is equals to, let's say, so this person name, who is he? The Rosen Franklin. Let me copy and paste it over here, and comma, and this William Gosset, right, saying it here, right, and I'm saying that one more thing, the columns. So what columns that you want? Of course, I'm saying that columns is equals to, so the occupation, right, and the bone, and we have something called this died, right, and I'm saying that this is age, right. So we finished this. Now let me run this cell, right. So I'm saying that the scientist, I'm running this cell, we got this. Only the changes between this 9th cell and this seventh cell is explicitly have provided the indexes in column. The data is the data. The data is this particular thing. And I intentionally said that I don't want the sequence of numbers for the index. So I said I'm providing my own indexes. So I have provided the Rosalind Franklin, the William Gosset in my index positions. So I said these are the columns in occupation, born, died, age. So I said the occupation, born, died, age. So this is a very good, and we have seen before only the index with the sequence of numbers all the time. So now at the time where we have changed the index names. So let's say if you wanted to, access this particular Rosalind Franklin data, what do you have to do then? Simply, yeah. So saying that the scientist, because this is the name that is actually holding this complete data. So we have to say the scientist dot lock. I'm taking it. When you take a lock as a method, the lock method which only identify the row names. So when I'm trying to retrieve the Rosalind Franklin, I must have to provide in the form of this way, the Rosalind and Franklin, right? So if I'm running my cell, it's going to tell you the occupation for this particular Rosalind Franklin is, the occupation is chemist, and he born on this date, and he died on this date, and age is this. If you want to access this one, let's say the same way, the scientist dot lock of William Gosset. So simple is this way, right? So, but if you're using this, let's say scientist dot, I'm using ilock over here. If I provide the same way, the Rosalind Franklin, so we're going to get an error because the ilock works only in the index space. So that means it doesn't matter what you have at the index positions, but it is going to say only the 0th positions. It only pull the data on the index basis. So the Rosen Franklin at the 0th index, and this is at the 1 index, and we have so on. If you have the more data, so ilock, if you choose an ilock, you must have to provide the indexes, not the row names. So I must have to provide the 0 here. Then I'm going to get the same day. But if you're using lock, you must have to choose the row name rather than choosing now the indexes. So let's say if I am saying this sign test dot log of 0, it is not trying to find out, it's not able to find the zero index, the zero row name in the data. We don't have such, so it is going to retrieve an error simply. But if I'm using ilog, then it's perfectly right, because ilog works only the index basis, right? So coming to the point here, so if you wanted to access only the indexes, what indexes that this scientist holds, you just need to say here, saying that here, say the scientist dot index. Say it's going to retrieve what are the indexes that are available for this particular scientist data. So we have indexes as the Rosen Franklin and William Gosset. But if you wanted to retrieve the values for this, let's say the scientist dot values, right? So the values for this particular scientist, the Rosen Franklin, is chemist this, and for this thing is this. So what is basically here the index is an attribute, right? And values is also an attribute. So these are the attributes which will help us to retrieve the indexes. And if you wanted to know, and if you wanted to retrieve the particular column, then you can actually retrieve that, right? Then it's going to get this way in the area of the values. All right then. And suppose if you wanted to pull the data of this age column, how are we going to do? The scientist of age, simple. If you want to access this one, then you have to say you have to use any of the methods such as log or ilog, as you're already familiar right now. But if you wanted to pull the columns, any of the columns, occupation or born or died or age, you must have to say the scientist of age, right? So let's going to pull out this ages. So let me check the ages is equals to a variable, the scientist of age. So I'm going to run this. It's not going to return anything. Now it's going to tell us now Rosen Franklin age is 37 and the William Gosset age is 61. Or why we are getting these two instances? These are the indexes. These are not something else, right? So I can do some kind of operations on this. In the if you wanted to find out what is the average age for this two scientists, let's say the print of, let's say even you can use the print function, or you can actually say the ages dot main directly. Then it's going to tell you what is the average for these two. The scientist age is this. If you wanted to find the minimum age, let's say the ages dot min, then it's going to tell you the minimum age is 37. We have only two. We know that this is a minimum, this is a maximum, of course. But if you have a larger data set where we want to find out these, calculations, we have a very flexibility. Since we already have a methods, then we can actually able to pull out. So age is what type. In fact, so if you can add a cell over here, then if I wanted to know the type of this ages, simply it's going to return a series. On the series or a data frame, if you're trying to apply this mean or trying to find out the mean, it works on the column basis. So the minimum. If I'm trying to pull out, let's say the maximum, so it's max this. Let's tell you 61, right? Right. So the next one is, let us go and pull some data from my GitHub account over here. So we have a scientist data over here. Where is it? This is the one. So let me check this. And we have this much of data. So we're going to work with this data right now. So I need to take a raw file, and I have to copy this, and I have to go to my data structures here. Then say we know that how do we read this CSV file normally. So let me say the scientist, and again taking the same variable, never mind. So the pd dot read underscore CSV, then we have to provide this link, and I'm running this cell, and scientist dot, we need not, because the data is very less, we need not to use the head or tail methods. It's just going to retrieve all the data right now. So we have this data. We have same data that we have generated in the previously, but this is actually there in my GitHub account, so I'm using it. So we have about age, length. We have every scientist's name and their occupation and when they were born and when they were died, and what is the age of their scientist is this, right? So if you wanted to get the basic statistics of this particular ages, let's say, first of all, we need to subset the data. So let's say, as I said, ages is equals to anything you can actually take. It's not an issue, right? Any variable. So the scientist of age, right? So I'm checking it this, and I'm saying ages. Ages is this. I'm subsetted it. So if you wanted to find the basic statistics rather than just pulling out every individual mean, maximum, right, minimum things and all, you can directly get through one method. The method is a describe method. So if you say that age is that describe, so it's going to give you the basic statistics of this particular ages data. So the count is 8. We have count 8. If you can just find count it down, then we have a mean of this, right? If you just calculate all of them, if you just add up all of them and divide it by 8, you're going to get this number. The standard deviation, we have a special section for this. Anyway, and we have a minimum is this. We have 25% of this. It's a bad idea to just calculate to 44 25% and 50% 75% from this ages data, but I'm just trying to give you the overall idea about this describe, because it's going to retrieve the basic statistics. What is going to retrieve? The basic statistics about data. So the maximum is this, right? So coming to the point here, if I can say, we can do the same individual also. If I can say, can you just try to, if you wanted to subset our ages by identifying those above the mean. Let's say my mean is about the 59.12, right? If you wanted to retrieve the ages only above this mean, how do we do that? It's a good question, right? We don't want the scientist who is below the mean, but I want to have my scientist data to be retrieved only the above the mean, right? So let's say first of all, you came to know that even if you wanted to have this mean, again, the ages dot mean, you can also retrieve this way. Say it's the same value, the 59.125 and 59.125 over here. And let's say if I wanted to pull the data which is above the mean, so what I have to do simply, the ages of, right? Say ages greater than, right? So ages greater than ages dot mean. Simple as that, but it's going to retrieve the true, false things, Boolean values. The problem with this is it is telling that the 0th index, that is, if you can see this, the 0th index 37. So I'm trying to retrieve the data which is above the mean. So the 37 is less than 59. So it is a false. So it is not considering that. However, you're going to get the data also, don't worry. It's a true in the sense, the second one, the 61, definitely this is greater than 59. So it is true. So it is trying to give you the Boolean values. If you want to get the data rather than getting this true false things, you just need to say that age is of, right? Age is of this. The ages of false, it's not going to retrieve. The ages of true, it's going to retrieve that particular data. So if I run back this cell, this is the thing. So we have only 4 values which are there above the mean. So who is above the 59 age? That this. So 1, 2, 3, 7, right? Good to go. So let's say, so what is the type of this? The type of, I can say that this type of the complete, this particular thing, if I can say for you, right? So taking this over here, the series object, right? Make sure you don't forget these things. Yeah. Let's say if I manually wanted to retrieve the values, right? You can even, I can say that, say I can create a Boolean of values even if I want to do, because I have shown you something that if you're not putting this thing, under ages, it's going to tell you that true false things, right? Even I can actually pass same way if I wanted to have, let's say manual data is equals to, let's say the true I'm saying, false I'm saying, true, false, right? True, false I'm saying. And we have 8 data, right? We have 4 and we have need to have a 4. True, false, 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 right? Then I'm writing this, and I'm saying that here. So the age is off, right? The age is off manual data. Say, got this thing? Yeah. Only the true things. 1, 2, 3, 4. We have 4. I have got retrieved the 4 true things. If it is a false, then it's not able to retrieve that. Same way. So same way which is happening over here. So let's say if I'm reducing one thing from this list and rerunning this particular cell right now and coming to this, it's going to give you an error because we have about 8 values in the data, but we have only provided true false things only 7. 1, 2, 3, 4, 5, 6, 7. So which is missing another one. So that is the reason it's not able to retrieve. We have to at least to say false or true. Otherwise, it's not able to understand whether what you have to do, what it has to do with that particular rest, the left one value. So you can say that here true or false, whatever it is. Bad. True. So I'm saving it, I'm rerunning this cell and coming to this, I'm rerunning this cell. Same way, we have 5, 1, 2, 3, 4, 5. All right then. So the next thing is if you want to perform any kind of operations between two columns, let's say the two vectors, we also call it as, let's say, this is one column. We also call it as a vector. This is one other vector, vector, vector. So if you're performing any operation between two vectors of the same length, the resulting vector will be element by element calculation of the vectors. Let's say you might be understanding this right now. Say if I say we got the ages, let's say this, we got these ages, then if I'm saying that the ages plus ages, so that means we're trying to add the ages and ages. So what's going to happen normally? We're trying to, what is the type of this? Let's say first of all, if you wanted to know, what is the type of this? All right, so the ages, the series object, right? Series is also called as a vector. That's what I'm saying. So if I say the ages plus ages, what's going to happen in sense is going to append each value of the vector. So that means, so if I'm running this 37 and 37, 74, right? 61, 61, 122. Likewise, all the elements gets added together if you're trying to add it together this way. So what is this called in a sense? We call it as this. Say, I'm going to add a cell over here, make a markdown as a heading there. This is, we call it as performing, it's a broadcast. That means if you perform an operation between two vectors of the same length, the resulting vector will be an element by element calculation of the vectors. So it's simply calculate, it's trying to add with this same number with the other, same ages. So we understand this is a few values, a series of values with the you're trying to add with the other series of values. But if it is on the same length, it is going to be appended this way. Yeah. Even if you're trying to do the ages into ages, simply going to return all the things this way. So that means the 37 into 37 is this much. So 61 into 61 is this much. 90 into 90, this much. So yeah, I'm going to take a next step. So if I'm trying to say, this is something that we call it as we're performing vectors of the same length, right? The same length, right? So now ages, we have age. We're also adding on the same ages. So it is going to be a same age, same length. So you're trying to get this way. Yeah. Coming to the point, if vectors with integers, let's say integers that we call it as scalars. That means instead of making on the same length, I'm going to perform something as say ages plus 100. So what do you think? So that means when you perform an operation on a vector using a scalar, that means this is, we call it as a scalar because the length of the ages is 8. You're trying to add 100. Is it going to result an error, or is going to append it, is going to add 100 to each element in the ages? So you're going to see that. So the scalar will be recycled across all the elements in the vector. Simple as that. That means say what's going to happen. Bad. So there is something. All right. So we need to cross mark this. Okay. We had, when you think that, like I'm going to add this ages here. Okay. So simply 30 plus 100 is 137. 61 plus 100 is this. So this kind of a single one integer, you're trying to add it to the ages. The ages has a series of values. A series of values gets added. Each value gets added to the 100. And that is the sense where you actually get 37 plus 100 is 137. Right? You're going to add each value to the 100. Simple as that. Even say right now here ages ages into 2. Say this 37 into 2, 74. In the same way it's going to be happen. Let's say right now the vectors, that means series with the different lengths. Yeah, because when you have seen this, see the ages with ages, that means on the same length you're going to get this 8 values. If it is a scalar, you're going to get this one. But if if you have two vectors with the different lengths, what's going to happen? Then you must have to know. So let me mark down this and running my cell. See, let's say ages plus. Then I'm trying to add another series of values which is on different length. This ages is we have about 8 length. I'm going to create a pd.series, right? I'm saying that 1 comma 100, let's say. Now, what do you think? We're going to get the missing values because this length is, we have only 2 values in it. We have 8 values in this. What about the rest? Because how it's going to perform addition operation there, right? Say 37, we have 37 right here, 37, right? 37 plus 1, 38. And the 100 plus 61 is 161. We don't have any other values in the PD, series. We have values still more with the ages. We cannot say that a number plus nothing is equals to that number. If we can say that the number plus 0 is equals to that number, right? But you cannot say that the number plus nothing, it's not 0, I'm saying it's a nothing. When you say the number plus nothing, it cannot be something, right? That is the reason it's saying that it's nan. Nan in the sense not a number. Remember, it's a very important thing because we have a special section about this nan, about how do we handle the missing things, how do we replace missing things, how do we remove the missing things and all. So there we're going to deal with the big data, right? It's very small data, I understand right now. To make you understand clearly, I'm trying to minimize the data right now. You have to be careful while doing all these operations. See, we're trying to add ages with a different length. That means vectors, series, vectors with the different lengths. A vector size for the ages is 8. Series, if you're confused as, let's say the pd dot series, s should be capital there. Let's say the 1 comma 100. Say it only has two values, 100. These are the indexes. So if you can see this here, let's say, if you can see this here, ages, we have 8 values here, right? So 8 values, it's fine to, adding it to the these two. But how about the resting? 66, we have 56, we have, we have 90, 66, 56, 45, 41, 77. So those cannot be added because there is nothing there. If it is there as simply as a 0 at least, we can get this number. That is the reason we are getting this nan saying that it's not a number. So say the 37 plus 1 is 38.0 because we're trying to add it there. The 61 plus 100, 161, very fine. But what about this 90? That we do not have any other values in this 50 cell row. So what we going to get it? If it is 0, we're going to get the 90, but it's nothing there. So the number plus nothing is nothing. It is not make an operation to that. That is the reason it simply says that it's not a number. It's not a number. It's not a number. All of them. Yeah. So even if you perform same kind of operation, through the NumPy, where we can actually import NumPy as this way. Don't worry, we have a special section for this as well. NumPy as NP. I'm running this cell, and if I say that ages plus np dot array, there is another topic there, of course, 100. But if you say this way, you're simply going to return an error, because if you're trying to add a vector with NumPy kind of thing like this, it's simply going to return an error. Operators could not be broadcasted together with the shapes. The shape is different. The shape for this, Pandas has a very flexibilities. That is the reason, even if you're trying to have a different length, it's going to return at least an ans. But if you're trying to make same kind of operations with the NumPy, it is simply going to return an error. Say, value error, you can actually read this, operands could not be broadcasted together with the shapes of 8 and 2. We have 8 elements in the, ages column. We have 2 elements over there in the that we have array that we have created here, right? So it's simply unable to match it and unable to make an operations together. So broadcast it. That means we are trying to make a broadcasting the values, how it's going to be if I increase the value about this much, right? So don't try to do this way. But if you're trying to do on these, pandas, it's simply going to return nans, right? Rather than giving an error, even if you have a different length of vectors. So don't do this. So let me put a comma, comment there, running it. Yeah. So let's say, one moment. All right, now let's try to retrieve the data of the scientist. This that we have already created. Now we have this data. We have imported this data from the GitHub, right? This is the data that we have, grabbed this from the GitHub right now. Now, let's say I wanted to retrieve the data who is above the mean. The same thing that we have done over here. Let's say, let's go up. Let's go up. All right, this is the one. So we have retrieved the data who is above the mean. That is, we came to know that the mean for the ages is 59.125. So those who are trying to retrieve the data above is 59.125. So the same way, I wanted to retrieve the data, the same thing, but I want to have all the columns to be included, not just the ages. So the same operation, I'm saying it, but I wanted to retrieve ages above the average of mean. So let's say, how do we do that? Scientist. I said, if you're trying to, now because we are talking about this age, right? The same thing I'm going to include it, but we want to have included all the data rather than just age. So saying that ages, scientist of age, I'm talking about this particular column, right? Age is greater than the scientist of age, right? Age dot mean, right? This is something that it's going to return a mean value for the scientist of age. Now, the scientist of age, which is greater than, is greater than mean. So it's going to tell you the Boolean value, same thing. Oh, my bad. So what is this? So scientist, we made a mistake somewhere here. All right, the spelling mistake. So it's going to say saying the same Boolean values, false, true things and all. But we want to have the data should be included rather than just getting a Boolean values. So how do we get through of those things? Scientist, right? Of, just put everything in this bracket. So if you can say this, now you can say that. Now we were actually retrieving the data about ages previously. Now you're trying to pull the data of which is greater than mean of age of all the columns rather than just pulling up only the ages, right? So even you can actually say that, scientist.log, right? And you can say that true, okay? But you need to provide in the form of another list, because when you're trying to retrieve the more than one value using a lock or iLock, you must have to say in this way, true, false, false. You have only 8 values in it, right? So let me say the true, the true, the true, the false, the true. We have 4, right? Now look at this. Only we got 5 because the rest of them true, false over here, false. We got 3 false out of 8, so we got 5, right? And coming to the point, you can even, subset the data in this way rather than just writing this much complicated. If you want just the first half and the last half, something that way, you can even say that, the scientist, the scientist of 4, you can actually say the same thing, the first 4 with the including all the columns. If you want the last 4, let's say the scientist of the last 4. Simple as this way. So I'm just trying to put the 4 at after colon and 4 at before colon to retrieve the last one, the last 5 data, right? So now let's say if you're trying to perform the scalar operation that we have done just before, if you're trying to perform the scalar operation on the complete data frame called scientist, so what's going to happen? So it's simply, it is going to retrieve a multiplied by 2. In fact, see the Rosalind Franklin, it was repeated, right? The Rosalind Franklin, again Rosalind Franklin on the same data, right? Right? Same times, 2 times it was repeated. So because you need to understand, you're trying to apply the scalar operation on the data frame. When you're trying to do the same kind of operation on the series, it is trying to multiply with it together, right? Values, we got the 37, you're trying to multiply with the 2, you're going to get this number. But when you're trying to apply on the data frame, it may not be calculated in the same way. So when you're trying to apply the scalar operation on the data frame itself, so it is trying to multiply by 2. That means it's trying to give you 2 times, 2 times, 2 times. But how about this age? Now the 2 into 37 into 2, it becomes 74. Ages can be calculated, but the remaining odd, it's not, we cannot multiply by 2. That is the reason it's going to give you this way, right? So make sure before you perform any kind of operations today. And one more point, the most important point here, because we have most of the situations in the real data, we don't perform the complete, operations on the complete data, because you're going to see in the millions of the data. So rather, you just focus on retrieving the sample of the data from, date ranges. If you can just observe right now here, the scientist data, right? I'm just trying to print it again, right? Right. So we have a born and died columns, right? So what is the type of this born and died columns? How do we know the type of this born? Say the scientist of born. Say the series, and the type of scientist of bone, yeah, of bone. So, right, series. But if I wanted to know what kind of, what types of values it is holding, I can simply say that the scientist of bone, right, D type. It is object, O is instance object. But this is something not, we can work on the datetime operations. Because if I wanted to retrieve the data which is from only this date to some other date, let's say, how we can able to retrieve? Because it is under in the string formatted. The equivalent form of the object in the Python is string. So we cannot really perform a date time operations on this particular born or died data because it is in the string form. So how do we convert this born or died dates to a proper date time formats? So in order to make that, right, if you wanted to convert this born date to proper datetime format, let's say I'm going to take someone variable as datetime, right? The PD dot, we have a function called to underscore datetime, right? It is another function which is from pandas only, which is going to convert your a proper datetime, proper dates to a proper datetime format. So how do we get this done? Scientist of, I'm forwarding my column here, right? Now, if you can see that right now, we have in the format of year, month, a date, right? We have all the dates in the same format. So you can actually provide this a optional parameter saying that you have to give it in the format of a string itself, percentile capital Y, and then we have a month there, percentile m, then we have a month, the date there, right? I'm going to say born underscore date time. Now, what is the type of this right now? Now, if you can type saying that the series, of course, we know that, but if you wanted to know the exact type of this, okay? So born underscore datetime dot d type. What is this? What is this? So it's basically in the time, timestamp, the values are in the same form, right? So if you can even observe there's the born date time right now, it is not in the form of this because we already got this type is nanoseconds wise. So it's going to tell you the hours, minutes, seconds also. But it's purely timestamp. That is a purely converted. So we can actually make a lot of operations on the datetime right now with this. But if you have just in the string form, you cannot really make any operations on the data, right? So if you can run this right now, see, purely tell you the date time 64 ns, nanoseconds wise.
Okay.
Yeah, you can even convert this in the same way, the died column as well, if you wanted to. Let's say I'm going to take the died date time, right? The pd.to underscore date time. So it's function, as I said, the scientist, right, of died, okay, and comma format is equals to, right, and the percentile y, the hyphen there, m hyphen there, because we have hyphens only there, right? If you can look at the data, day, this, and they died underscore date time, say, is also date time formatted, right? You have to make sure in that way. So if you still, let's say if you wanted to find the how many days they were lived, that means you wanted to find the difference, how many days you wanted to the difference between this died date and born date. If you want to get the difference number in the number of days formatted, so how do we get that? Let's say the scientist of age, let's say I'm taking another column, age, days, and the date formatted, right? Creating one other column over here. That means we don't have that column which is there in the scientist, but I'm going to create it right now. Yeah. So what we can say that uh, first of all, you need to convert them into let me say my bad. So let me say first of all we need to convert them into this the bone underscore dt. We don't have this column as well, right? And we don't have this column as well. Let's say the diet underscore dt is equals to, yeah. So I'm saying that here the bone underscore date time we already created there, the diet underscore date time. That means I'm going to create a new columns in the sign test, bone underscore dt and date underscore dt. So what is the difference between, if you can look at this right now, if you can say the sign test, say these are in the string formatted, that is object formatted. Now I'm going to add two other columns into the same data we're going to get here, right? And the values for the bone data is bone to date that we have already created these things. And died to date is this. So why you have provided in the form of this, in the form of tuple in the sense, so those we cannot change it. That means, right? If you can also, if you want, you can actually provide in the form of this if you want it. Let's format it. Say. Then if you say that sign test, then we got two columns. It's going to be added if you can look at this comparison, right? And let's say right now, if I'm going to create the difference between this date and this date, so we're going to get it in the form of days. So in order to get that way, the sign test, I'm going to create another one, as I said. Yeah. So what I'm going to do here, ages, let's say I'm going to take one other column as ages difference. Whatever you can actually take it, it's not an issue. Let's say I'm saying that the scientist of, right, scientist of. So in order to get the positive days, we need to subtract this died minus born, right? So I'm going to take this died underscore dt, right, minus the scientist, sorry, yes, exactly, scientist of born underscore dt. So simply running it, the scientist. So this particular scientist, Rosalind Franklin, he lived these many days, 13,779. See how surprised it is, when you're looking your lifespan in terms of days. It's a very funny thing, right? So this person lived these many days, 22,000. Very good. It's very good. His person is 32 days, 32,000 days. So this person lived long, right? If you can just count your age also till date, it's just going to be in the thousands, not going to be very long. So if you don't look at your life in terms of days, it's better to live, look at your in terms of age, years. All right. Well, all right. So one moment. So one last thing over here, say, if you wanted to know the scientist at columns, it's going to retrieve the columns here. Columns here is an attribute again. However, say we have these many columns. If you wanted to just drop down this age column, let's say, how do we just drop down? That means I don't want this column to be there. Let's say, how do we drop down that? So the scientist sign test dot drop, okay, saying that age column I want to drop out, okay. So the axis is equals to 1, so it is looking at the column wise normally. Then we don't have age column, which was there in the previously, but I don't want that column to be there in my data, so I simply taken out. That means I removed it, right? Even if you look at this in the column basis, columns right now, we don't have ages, right? So make sure. All right, so this is, you have to say in place equals to true. All right. Only the point is, it is equals to. So in place in the sense, basically, we don't have, but because I'm running it the second time, it is already run. Okay, don't ever try to run again because it's not there, right? Then if you wanted to get that back again, then you have to run all the cells again. So otherwise you don't see this. Yeah, let's say here I'm saying you don't have the ages. So because we already dropped that at the in place, now you look at the columns right now, there is no age column over here, right?